To problem 4.22 from your mastering homework. These problems, we're going to do 3 of them from the set of, I think there's 5 here. We're just going to do 3. Part A actually stumps students, and the reason for that is because if you look at page 135, you will see that silver is an exception to our typical transition metals, and it only forms a +1 charge. Okay, and so we do not have to include a Roman numeral for this naming. So we're just naming these ionic compounds, and so we would write out silver for Ag. We need to look and be sure you know that that symbol is for silver. And then we have a P, and that stands for phosphorus. So we drop the ending, and we end with phosphide. We drop the E and add IDE. Okay, if we go down to, let's do C, and we will do the naming for this compound. So we're given the formula, and if we find tin, we know that it is also, someone's one that gives a little trouble, but if you look at page 135, tin and lead there, they form more than 1 ionic charge. And so we have to use a Roman numeral in this situation. Okay, and so we're trying to name, so we're going to write out, so what we do know, we know that we have tin, we're going to have to use a Roman numeral, and then we have oxygen. So if we drop the ending, we have oxide. Okay, and so we've got to come up with what our Roman numeral here is going to be. So what's the oxidation state or the ionic charge of tin? Okay, and so if we have 1 atom of tin, okay, and so this is, we're not sure what our charge is. Okay, so if we're looking at, okay, we've got 2 oxygen atoms, and we know that oxygen has a -2 charge. Okay, the reason for this, just a reminder, oxygen is in group 6. Okay, it needs 2 electrons. It needs to gain 2 electrons. So if you go back and look earlier in chapter 4, it needs a 2- charge. If it has a 2- charge, it's gained 2 electrons to become like the nearest noble gas. Okay, and so this all has to equal 0. Okay, and so if we plug in for x is going to have to be equal to 4, because 4 minus 4 equals 0. So we would have 10, 4 oxide. Okay, if we go on down to E, I believe, let me get my mouse back here. We have a transition metal. It's the first thing we want to notice. And so we know we're going to have to use a Roman numeral. Actually, I want to go down to this one here. Okay, so we have cobalt, we do not know the oxidation state or the ionic charge yet, and we have chlorine, which as chloride has a -1 charge. Okay. You'd have to know, so when we're naming, we would say cobalt, then we would have Roman numeral. Okay, on the mastering, I think it's accepting with a lowercase. So I know in another video it's uppercase, but I'm not sure if it accepts with the uppercase first letter of the metal, but you can use lowercase. I know it does accept that. So you see it either way. Okay, we know chlorine becomes chloride. And so now we have to find what the oxidation state of our metal is. So we can say here that we have, in COCl2, we have 1 times X, what we're looking for, plus 2 times -1 equals 0. Our charge has to equal 0 in order for us to have a complete octet and for everyone to be happy and to have a charge of 0. So we have 2 atoms, so this number here comes from how many atoms that we have. We have a -1 charge, so that's here. Okay, so our X is going to have to be equal to 2. 2 minus 2 equals 0. So we would say cobalt, Roman numeral 2, chloride. Hope you can finish the rest of these and get them correct. Thank you.